Okay, I think my mic is on. Testing. If anyone's here, let me know. It looks like I can see audio going in though, but if you can always, I don't know, double check that you can hear me or see me, especially because my mic was off, let me know. And while you're doing that, while people are joining in, let me send a live reminder on Luma because I forgot to do that. And as you're joining, if you want to say hello in the chat, where you're watching from, that's always really fun. What you're building or learning is also even extra fun and kind of cool, not only for me, but also I think for all the attendees as well. So let me just get this blast up real quick. We are live. Luma changed something. All right, let me I see some people joining in. Hello, how's it going? Let me bring up my screen actually too. It usually takes a couple minutes for people to roll in, so we'll get going here in just a couple minutes. But again, as you're joining in, say hello in the chat where you're watching from. What are you building? What are you learning? It's always fun to see. Let me just try one thing real quick on Luma to send out a blast. It's doing something a little weird, but I think I can get around it. All right. All right, seeing more people come in. Hello again. Welcome everyone. We'll get going through some slides and then mostly code here in a little bit. Again, as you're joining, say hello. See, one person says gotcha in the chat. That's all I see so far. Quite a few RCPs for this one too, but you never know the turnout rate of events, so it'll be fun to see. But if you're joining in, again, I don't know, do you have any applications right now for like post-training or fine-tuning LLMs? Have you been playing around with it? Is it for work? Is it for just for fun? Let us know in the chat. All right. See quite a bit more people joining us. So again, I'll repeat myself usually at the beginning a lot. Welcome everyone. Say hello in the chat. It makes it way more fun, I think, for definitely for me, seeing that people are here. If you want to say where you're watching from, that's really cool. If you want to share what you're building or learning, even better. And if you have any specific use cases around like post-training LMs, would love to hear them. If you've tried implementing or running like GRPO or some other reinforcement learning post-training thing, especially, that's always fun to hear about. Or if you've done like full fine-tuning as well, that's also cool. So yeah, just kind of curious. It's fun to kind of get a little bit of a temperature of like where people are at in terms of their like machine learning journey too. Cool. I see somebody said they're from Berlin. Ooh, hello. What time is it there? It's got to be pretty late there, right? And someone said from California. I always love going down to California. I'm in Seattle myself right now. But I go down to California quite a bit in the San Francisco area. So I'm excited to go back. Maybe even next month, actually. I think we might be doing something down there. So keep an eye out. All right, I'm just going to wait another minute before we get going through some stuff here for people to join in. Yeah, pretty late in Berlin. Someone's from Utah. Welcome. I might have driven through Utah once, but I haven't gone there and hung out. It always seems really beautiful. I would love to make it out sometime. And Daniel's from North Carolina. Awesome. I read that as North California at first. I've been to North Carolina before. Went hiking out there once. It was pretty cool. And someone else is from Seattle, and someone's from Chile. Awesome. It's really cool to see like people tuning in from everywhere. I love seeing that. All right, so I'm going to go through some slides here. I'm going to share some code as well, and I actually might go bring up another repo to share too for a couple things. So I'm going to share, if you want to check out this GitHub repo, this is going to be a lot of the code that I'm walking through. I'm actually going to go take a step back too and grab this other GRPO one that is actually for code. And I actually might walk through some of this as well. The pipelines are very similar. The code generation one has a couple other features. Well, that includes like a sandbox. So it's doing the LLM is generating code, and usually when that happens, often most of the time, you want to generate that in like a safe environment where if it does code execution, it's not going to ruin anything. So it uses sandbox for code generation, and then it gets the it calculates the rewards from that success of the code there. So the pipelines are actually very similar, and I'm going to talk about the pipelines more in depth here in a second. And actually, I guess before we go in the slides here, I'll do that a little bit. So the first one I had shared is mostly what I'm going to be walking through for this kind of workshop and talk kind of thing. And a reason is because this is something that can actually run pretty quickly on a small GPU. And so I was making this workshop so that we could run this together on T4s that we have in a cluster that I was going to give you access to. But sadly, there is an S3 issue right now with our cluster that I usually give out to people with the GPUs. So I can't onboard you to the cluster like I normally would. So I'm going to walk through all the code. And if you wanted to, you could run this all locally with open source Flight, which is the orchestration platform that we're going to use. I'm going to use it hosted on Union. But you don't have to do that if you just want to watch me walk through the code. But usually I have people like with access to GPUs, and you can run this. But I really apologize. I wasn't able to make that happen. This morning is when I found out the error. So this workshop is kind of all around this pretty small large language model. And we're going to use GRPO, and we'll talk about what that is in a little bit, but it's a reinforcement learning method for post-training a large language model to adjust behaviors. You can do that for all types of things like making thinking tokens. That's like one of the biggest use cases. This GRPO came from DeepSeek. We'll share the paper here shortly too. But the big thing out of that was using GRPO for adding like reasoning into large language models more efficiently than other reinforcement learning algorithms that you could use. And then you have a really good paper on using it for math. So you can use GRPO to fine tune for like coding, making it better math, reasoning, adding behavior into models that isn't giving it a data set of example. It's giving it a reward based on how it's performing. So we're going to talk more about that as we go. But I just want to put it out there that normally I would have you follow along and give you access to something. But unfortunately, I couldn't make that happen this morning. So I'll be going through this code. If you do have a GPU, you could install this probably pretty easily locally and run it because it's a small enough model that I think it could run in something probably with like 11 gigabytes of memory, where you're going to use the Qwen half a billion parameter model. So it's fairly small. You can swap out the pipeline that I'm going to show you with different problems and much larger models. Again, I was making this as a targeted thing to run together in a workshop. So it's kind of small on purpose here. But unfortunately, we can't run it. And if I would have known that, I probably would have just done a bigger problem in the first place. But just a little setup for it. Oh yeah, and somebody said they can't use Google Colab for TPU. So yeah, you could git clone this down into Colab. And actually, they have a Colab CLI now, I think, too, right? Where you can maybe run the compute from your CLI. I haven't tried it. I saw like a headline around it. So you could run this in Colab, git clone it down, and run the commands in there. And I wasn't able to make the Colab book before that because it was an unexpected thing. So apologize. Might be rambling a little bit here too about that, but that's just what happened this morning. Also, if you want to stay connected, and if I can get this up later and you want to run it, or just want to hang out with a cool community, you can join our Slack or ask me questions about what you see here today or implementing this in your pipeline. You'll be able to ask questions about that in Slack. So we're going to do post-training on a large language model. Again, it's going to be a small one today. We're going to build a pipeline. So it's going to like prepare the data, download our model, and then we're going to train our model. And then with GRPO, and then we're going to evaluate it and see how much it improves. And just a spoiler alert, you can see it improved quite a bit. And we just did this with a few epics here. So if we give it, more data or more epics in this case, even, I think it would learn quite a bit more. But we're going to run through that, and hopefully that's still super interesting if you're up for watching it. All right. Tiny bit about me. and then tell me about you. Another call to action for you to talk in the chat. My name is Ed Gillett. I work at Union AI. I'm an AI engineer, and I live in Seattle, like I mentioned. A lot of people also know me for running an AI book club where we've been reading a new book every month. And again, join the Slack group. We talk about the books in there. Previously, I've done a lot of work in computer vision, ML monitoring, evaluation, MLOps, and former kind of background in hardware and IoT and a little bit of robotics. And I still like doing some robotic stuff on the side. If you want to connect with me on LinkedIn, you can do so too. Here, just copy that link, not open it. So if you want to stay up to date with other events or see more like blog posts of content like this for in different applications, like I'm working on GRPO for code fine tuning and a whole bunch of stuff that'll be fun, I think, for like more scaling rollouts and stuff like that. So if you're interested in this topic, which I assume you are if you're here, connect with me and hopefully you'll see more soon on it. So LLM post training with reinforcement learning. Why do you need it? And again, in the chat, has anyone done like reinforcement learning fine tuning before for large language models? Or are you poking around at it right now? Or have you done, I don't know, full fine tuning, full supervised fine tuning before? So with the LM post training with RL, it's useful because the supervised fine tuning teaches model to imitate examples. So you usually need a data set where you give it, this pair, and you're trying to have it start mimicking that or learn some data from there. But with reinforcement learning, you kind of teach it to go, like you nudge it towards an outcome, and we'll kind of see this in action and break it down a little bit more in the README and some other stuff in the slides. But you're basically, instead of giving it like a full example to start trying to imitate it, you can give it different reward functions or reward shapes, which we'll talk about too. That's a big thing in reinforcement learning, is figuring out what the reward is. So you could start with like a binary reward, and that could be like, just did you do the thing, yes or no? Or you could have rewards where it gets some amount of reward for being close to the thing that you're training on, but it doesn't actually like learn to imitate a full example. And then by sampling the multiple responses, like we'll see in GRPO, you score them with a reward, and then you reinforce kind of those best ones that you want. You can make the model more reliable at, again, things like reasoning, following instructions, using the right format, passing tests, or kind of matching desired styles. And it's really helpful when you can kind of judge, again, whether output is good or bad, or you don't have a perfect training example for kind of every use case here. And you can give it, again, that kind of reward function to it. And I'm going to talk a little bit about the reward function stuff too, because it's pretty interesting. If you haven't done a lot of RL before, when you first get into it, you'll find out some interesting stuff like reward hacking. Like your model is going to start giving you good results based on some parameters you set up, but then it's not actually going to be giving you the stuff that you want, because it can learn to sometimes kind of hack those rewards and again, kind of abuse them in a way where it goes up, but is not actually generating the results you want. Like if you've seen a classic reinforcement learning example that I've done some stuff with, like physical AI, like you train a humanoid type of character to like, walk around, and your reward function is to go forward. Like if you get farther forward, the better the reward, right? And if you don't give it other rewards or build up the rewards, like actually having it walk correctly, sometimes it'll just start throwing itself, like jumping as far as it can forward and falling on the ground. And that's not what you want it at all. And the same thing can kind of happen with like the LLMs, not in a physical way like that, but it can figure out getting close enough to the response where the reward is going up, but not actually giving you something. So we'll talk a little bit more about that as we go. So what is GRPO? The group relative policy optimization. So this adds trainable, this I left over. This is part of the LoRa thing, which is on the next slide. And this is the original paper. So I'll share the link here. Actually, I might go through part of this in a second too. But you can kind of get this is the gist of the GRPO is we have a prompt. So today, like we're going to train a very small language model that the base one does a terrible job at the problem that we want. And then we're going to use GRPO to nudge it in the right direction and then actually get some pretty decent results with it. So it's going to be similar to like kind of this example here, which is like doing a kind of like a little bit of a math puzzle. Ours is a little bit more complex, but this is just teaching it math in this case. So it's like a prompt where you're just saying, solve this equation, and it's going to try. It'll try, in this case, like it's doing a group of 4 of them. So it's going to try to solve it, and some of them will be good, some of them won't be. And then it's going to take all these rewards. So the ones that are good, they get like a positive reward, and the ones that are bad, in this case, they get zeros. Again, you can also do like negative rewards, reward shaping, and figuring out what to do. There's a whole thing where you're going to spend some time doing that, probably depending on what your actual application is for your RL. And then with the GRPO, it takes basically an average of all these different rewards, calculates them, sends it back to the policy update, where you're basically saying, these are the things that I liked. Like these ones were good. Again, I'm not going to tell you exactly how to update your weights and like mimic a specific data set, but I'm going to tell you which ones of these results that you did, again, kind of randomly, based on the prompt, which ones are good, and then which ones I don't like. And then it's going to start adjusting its behavior to match the good ones here. And there's other RL policies. So I think this is the paper that you should go dive into more. But you had PPO before, which is pretty similar. But the problem is that, or not a problem, but the reason why like GRPO came about is DeepSeek, at least I know theoretically, is like trained on a lot less powerful GPUs. At least they were at the time of these papers, and they had a resource problem of like, it was really computationally expensive to use like PPO. And part of the reason why is you have your LLM that you're updating and generating results. And then with PPO, you have another kind of value model that is kind of criticizing. It's like a critic model that comes up with a score. And instead with GRPO, you don't have that scoring model anymore. You're just taking the computation between all, or taking the rewards between all the ones that are generated, and using that instead of having something kind of criticize each generation. Here's kind of the exact blurb. I think in contrast to PPO, the advantage is typically computed by applying the generalized advantage estimation, based not only on the rewards, but on the learned value model. So it adds a lot of computation when you have that kind of other value critic model in there. And GRPO is kind of able to get around that and do this much more efficiently. The other thing we're actually going to use today too is LoRA. So LoRA is the low rank adaptation of large language models. Oh, thank you. Somebody said PPO, proximal policy optimization. And in the README for the thing I'd shared, it kind of goes into a little bit more. If you scroll down, like I put in some stuff around the different types of models to, at least I thought I did. Maybe I didn't push it up. Yeah. So like when you might want to use PPO or DPO, which is a different use case. We can talk about that when we get to the README if you want, but kind of a little bit of a breakdown. We're going to use LoRA for today's example too. If you again have even a pretty small GPU, you should be able to run this locally. LoRA's low rank adaptation. This adds a trainable low rank matrix to your attention layers inside around your large language model. So instead of updating all the weights in there, you're able to basically train a large language model on a GPU without as many resources either. So instead of updating all the weights in your large language model, you have these small kind of adapters off to the side that you can just update these and still get really good results on it. And Toronto developer is also talking about QLoRA. So I actually, I did a LoRA and QLoRA workshop. I deleted my slide in here from the LoRA workshop, but QLoRA is basically, then you can quantize this model down as you're learning or training it as well. So if you can't even load the entire model in, you could load in a quantized version of that model and only update a small weight matrix like this. So again, if you're pretty resource constrained or pretty GPU poor like me, you can still often train these models just at a quantized version, and maybe it's not quite as good if you could load in the whole model, but again, you get usually pretty good results with this. And like Toronto developer said in the chat, the quantized LoRA generally weights are stored in 32 or 16 bits. QLoRA is 4 bits without losing quality of data. Yeah, so you can quantize the model down. And actually the code example that I shared, the GRPO for code one, actually has a QLoRA parameter in there. So because with GRPO, actually, maybe I'll just talk about this now. With GRPO, because you're basically learning from the prompts that you generate, which ones are good or bad, it's really important that you have a model that can do the thing that you're looking for at least some of the time, because it's not, again, learning from like a data set. So if it's kind of, again, generating these based on the prompt, so you're saying like solve this math equation, if you're using too small of a model that can't do the task. So for example, I was actually testing this out because I was hoping I could get a really small model to run on like the T4 and do code generation. But like the Quen like 1.5 and the 500 million parameter could not generate good enough code, at least from the data set I was comparing it to. So it just couldn't actually ever get to any trainable things because it would never succeed here. And so it would have nothing to really give a reward based on. So that's a really big part of thinking about the RL type of side for this when you're doing those generation things like this. If your model can't do it in the first place, like it's just not going to learn from like GRPO because it needs success rates to have the optimization reward come back saying these are the ones I liked, these are the ones I didn't. So just keep that in mind. So if you're trying to use like a 500 million parameter model and you want to teach it to code, chances are, at least right now, from like the ones I've tried, that does not work very good. But there might be some data sets that would work with it that are more simpler. And I haven't tried a specific super like small 1 billion specific coding one, which I might go try next with it. But actually, does anyone have recommendations? Like if you wanted to do a super small coding model and try to make it better for your specific types of GRPO, does anyone have like a 1 billion or 2 billion parameter model? I think when I've been playing around, I'm getting success with like some 7 billion parameters. And with the T4s, I think I could load that up with a Q LoRa in there. And because I think the T4s have 16 gigs of memory or something like that. So. All right. So LoRa, quick about the tools, and then we'll get in the code here. Again, for people who's joined in, again, I can't give you the cluster today, which I normally do, which I apologize for. So normally I would go through, have you actually try to run this with me. Actually, quick question on that too. Well, a lot of people are still here with that. When I do these talks and workshops, quite a few people don't always actually run the code and they just like watching it, which is totally fine by me. But I'm actually curious, like if I did these as basically showing like what I'm going to show today, like I walk through all the code and I show like examples and I show something that ran, but you can't run it. Is that still like pretty interesting to most people? So I've been doing them as workshops, and I think people like the term workshop, but I know a lot of people actually don't follow along. They just like watching and then maybe getting the reference code, and you can feed that to an LLM now later if you actually want to run it. But while people are like here at the beginning, I'm actually curious because if I do more that are just kind of talk based and kind of demos and walkthroughs, but you don't have the expectation of like being able to follow along unless you have like an accelerator at home. Is that something still pretty interesting to people? Yeah, someone said they came for the workshop part. So yeah, again, I apologize because normally I do that as a workshop. I had a thing happen today with S3 that is stopping me from giving you the cluster. So I apologize for that. Some people are saying yes. Getting to interact with stuff is easier as well. I think, yeah, I mean, someone said you could just set up a Colab notebook and then we can directly work on it. I've done some stuff with a Colab like that in the past. So again, this, I didn't realize it was going to fail until this morning, so I wasn't able to switch it over to Colab. And somebody said, still interesting, maybe workshop is better for learning. Provide a code lab in text on the slides so we can do it ourselves if we don't demo. If we can't see it ourselves, we might as well see it work. Yeah. Okay. So mixed results here is what I'm seeing from people, though. Again, normally I do it as a workshop, so out of my control. Sorry about the tangent there. So we're going to use TRL, which is a library from Hugging Face. It's actually now, I think, just embedded in the Transformers library. but it stands for Transformers Reinforcement Learning. TRL is a full stack library where you get a set of tools for implementing like GRPO, etc. You can check it out on Hugging Face. But this is basically what it looks like. Here's a snippet from like the code that we're going to run. You get the GRPO config, and then we're going to add in just different configurations here. We'll talk about this more when we get to the code section, but pretty easy to set up. A lot of Hugging Face libraries make it really easy for setting up like full fine tuning, LoRa, etc. They have libraries that make it really easy, including PEF for LoRa and another Hugging Face library. If you haven't used it yet, again, you can go check it out here. It stands for parameter efficient fine tuning. This is where you can do add things like LoRa that we just talked about. And this is what the configuration looks like here. We just add in your LoRa configs, and we can talk more about this when we get to the code too. But usually you add in your low rank matrices to at least the attention layers. And then there's some other layers that you can add them into as well. And then we're also going to use Flight. I'll show the example on Union. You could run this all locally as well. On Flight, we have something called DevBox right now. I see a lot of questions in chat, so I'm getting distracted. I'm going to come back to them. So you can come back, or sorry, you can go ahead, and if you did want to set this up and run it locally, you can check out Flight DevBox here, which gives you kind of this whole platform. I guess let me just show the slide code. So I'll go more in the code here, but basically Flight gives you a whole bunch of stuff around machine learning, deep learning, but it's an orchestration or AI runtime framework where you define like the resources and container images that you want your tasks to run into. So historically, like a lot of companies use Flight or Union to train their computer vision pipelines, their large language model fine-tuning pipelines, basically any ML type of model, a lot in healthcare. You get this SDK where it orchestrates the compute for you. So like here, this is a GPU environment. I'm saying I want GPU, how much memory, how many CPUs, and then I can have a CPU environment. We're going to use this today. So when we like download our model, download the data set, we actually don't waste any GPU time. And then when we're training our model and evaluating it, then we run it in a GPU environment. And everything here runs in a Docker container. It's built on top of Kubernetes, so it scales out massively. So a lot of people come to like use Flight or Union when they're spinning up a training pipeline where they need to scale a lot and manage secrets for you. You can see the declared infrastructure runs in your cloud and on-prem, by the way. So this isn't a like serverless type of thing. This is like managing your compute. Every run is versioned, so you come back and you can have your embedded reports here, your training runs, and see like whatever type of things that you save here. Has caching, so like when we actually rerun our pipeline today, the prepared data download, this is just going to read from a cache results and not rerun. Caching is also really fun for building agents, is what I found. You can also just use the Flight SDK and without Docker, just like get this terminal user interface that gives you kind of a scaled down version of this. And if you're developing on agents and you have like a whole bunch of sub agents and then an outcome that you're working on, you can just cache all those sub agents and then just work on like the next step. And I found that was really useful. What else was I going to say? This is kind of what it looks like. So you orchestrate your pipeline in pure Python. So we'll see this in the code, but you write Python like you normally would. This is actually why I was thinking about it too. We could probably have this run in Flight and or just a Colab notebook like people were saying. So I'll try to probably make a backup next time so you can still run this, even if I can't give you a GPU cluster. A really good note. So I'll try to make sure I can do that for next time. But you're right. You have your Flight environments that you create, and then you write in Python like you normally would, including like async if you want. And then you just add a decorator on top of your functions, and then you're going to get all these things kind of very easily in your environment. And so scaling out for reinforcement learning is cool too, because you can do a whole bunch of like fan outs for rollouts, learn from that, and then kind of combine it back into your model. Normally, this is where I say, let's go ahead and run the code. But what I'm going to do is I'll show results, show it working, and then walk through the code a little bit. Oh, sorry. Let me catch up on chat. So real quick, because I think there's a few things that I missed. Someone said there is one caveat about these libraries like TRL, Unsloth. They are very petty in terms of versions and don't get along well since each come with its own version of transformers and other libraries. And I think like for TRL, I've used Unsloth a little bit, not as much recently. So with TRL, like you're saying, its own version of transformer. Because I think TRL is built into the transformers library now, right? Like it says, yeah, right here. I think the library is fully integrated with transformers. So I'm not sure if you're saying like when you need to update TRL, you'll basically have to update the entire transformers library. All right, so I'll walk through again where we're going to build a pipeline, and I can actually, I don't know, maybe kick off a run here even. So this one I know we have pretty good results from. And again, I was trying to keep this in a time frame that would run during the workshop. And so at the beginning, I would have you kick this off. And then by the time we're done the workshop, it should be done. Unfortunately, we can't do that. So this is our pipeline. We prepare our data, and then I'll walk through the code for this. We download the model, we train it. We have a report here. I need to update this report, but basically, this was trying to show per batch how the reward here. And there is a green line that's really hard to see now with all these things written out. And this was showing the average, basically, solve state for it. And you can see it's actually still going up. So if we ran this for more epochs, unless it's overfitting, which we'd have to check on evals, it's chances are that it would still learn more here from more epochs, unless again it's overfitting, which we'd have to check. One thing that's interesting too is seeing just the token count because we're training it to solve this kind of puzzle that we'll look at here. And it was generating more tokens, and then by the end, it's actually figured out exactly what we wanted to generate, and then it's just kind of steady there, which is actually what we'd want. Looking at token response is interesting. Like I like using this for if you're trying to add reasoning to a model, you can use as an indicator of like it's learning to generate more tokens at first and like add those kind of thinking responses in. And then same with like if you're generating code, it's just a signal while you're training, like what's happening, like is it generating way more? Is it now way less for some reason? So I like kind of having this during my training state. And then evals for this one, we were saying this is the base model that we took, and it was only able to solve 10% of the puzzles. Just in a few epochs, it was able to learn how to solve 50% of these. So a huge like 40% improvement here. Token rate didn't change again. This is just a useful metric if you're doing something like thinking or reasoning. I like having it there, but for this specific case, it's not that interesting, except for it always should be generating 7 tokens at the end of it. And this is kind of the puzzle. So we give it this, we give it a set of numbers and a target number, and then it has to correctly come up with a mathematical equation to reach that number. And we can see the base model, like it is given these numbers, and it generated this 6 times 8 plus 3. And then our GRPO version did math more correctly here with 6 plus 3 plus 8, and then actually equals 17. So there's a whole bunch of these puzzles. It's not perfect. We can see some still failed here, but it got way better just in the short amount of time that we ran this. So in the code, let me actually make sure in the README. So if you are going to run this locally, you just could clone this tutorial repo down, set up the Python environment. So if you're using UV, this actually is pretty easy to set up. And then you just install the requirements. I don't think you need a Hugging Face token for the Quinn model that we're using, but if you are using like another small gated model, like Gemma 2, I think is gated. If you're going to fine tune that, then you'll have to add your Hugging Face token here, and also make sure that you accept the terms or whatever on Hugging Face before it can download. And then to kick it off, you just say flight run, workflow, pipeline, and then we're going to pass in the number or the model here, and then some parameters like the number of puzzles it's going to try to solve, the max number in that puzzle, the amount of epochs, etc. All the parameters are kind of listed down here if you want to play around with them and kind of which ones what they do here specifically. And then this talks more how it works a little bit more in depth for GRPO type of stuff and the different policies that you might choose here. I'm going to go to the code, and then we can come back to this if you want, because I actually kind of have a bit of a hard stop at 1 today. So I'll make sure that we can get through as much as we can. So I'm going to go again to this fine-tuning GRPO. It's called Countdown. It's kind of that puzzle. And I'm going to go and click into workflow. This will be the first one we look at. Oh, someone asked about the slides. Give me 1 second. I can share the slides. 1 second here. Share. And then I should be able to hit with anyone. View. Thank you for the reminder. Try to do that, but I forgot. Oops. Share. Copy link. Sorry, I just don't want to share any other email addresses that are in the share thing. This is the slide link. All right, so inside this folder in that repo, this is the one that we're showing off here. We have a few files. We have like app.py, config.py. So if you're running this on Flight, it's in the repo, but you'll run a command or you just create this file that sets up an endpoint to run it on. Like in this case, I'm running it on this demo union thing. But if you're using just Flight locally, it'll tell you what to run here, but you just have like this local host 3000. That's going to be like your endpoint. Remote builder. This is a union feature where it's going to build the Docker images remotely. It's actually really fun because if you're on like an airplane with terrible Wi-Fi or something like that, you can actually just build them in the cloud really easily, and then it'll run them in your container. But if you're using Flight, it'll build them locally and then push them to your like local registry or wherever you tell it to. And then you have some things like projects and orgs that you can publish different or run different projects in. So if I go to, I guess really config.py is the first thing. So the core of, again, running something in Flight to kind of get all the things that we talked about here, like retries, versioning, caching, again, kind of like all these ML specific features, scaling out. You start with a Flight task environment. And again, this one, we are just giving it a name. We're starting from a Debian base image, and then you can add in different packages in a whole bunch of different ways, including like UV script, pip installing them. I'm reading them from a requirements.txt, but you can also do like apt-get and running commands. So if you want to set up any container without interacting with Docker, this just gives you a really nice like Python SDK to do it. Again, just in the open source too, it will build Docker for you locally and then run your projects in there. And then you request the resources. So if you're on a Flight cluster, you want to know, like you have GPUs in there, different types of GPUs, a certain amount of memory. So for this container that we're going to run whatever project in for this GPU one, we want 4 CPUs, 32 gigabytes of memory, 1 T4. In this case is what I put there. But if you have like A100s or anything else in the cluster, you can define it there. And then I'm reading in my Flight secret. So you can create secrets, and those are also stored in Flight or Union. And you can read them into your container as different token names if you wanted to. And then we have our CPU environment. It's very similar to above, except for we're not declaring a GPU. This is just a lighter weight one that we're going to use to like download the model and download the data set. So again, you're not wasting that GPU time. Like if downloading a model can take a long time if it's a big model. I was just messing around with image generation stuff, and some of those models are massive, like 50 or 100 gigabytes, and those are still pretty small ones or whatever. But they were taking a long time, and so I didn't like want to use a GPU during that amount during that time. And so you have these lighter weight containers that run those types of tasks, and then you only use a GPU when you need it. It can save you a lot of potentially cost, like if you're paying for the GPU, but also just like you're not hogging that GPU from another coworker or yourself in another task, which is pretty nice. So then we can go to the workflow.py, and this is where we're going to create the actual workflow that we saw and use the TRL library. Let me try zooming in if I don't know if it was too small before. So I won't go through every single line here. Here's our system prompt that we're going to give our large language model. Again, it's going to be that super small one in this case. Just as you're solving a countdown puzzle, you're given a list of numbers and a target using each number exactly once, and the operators plus, minus, times or divide, and parentheses, write an arithmetic expression that equals the target. Give only the expression, nothing else. Example, blah, blah, blah. So that's the system prompt that we're going to start with. And we saw that even just the base model isn't doing a very good job with it. And then we're going to, when we fine tune it, it does a way better job. We have some setup functions here. One of them is doing evals, basically just running the math operation there. I have this extract answer. I think right now it's doing fine, but I was trying to originally have it with more reasoning tokens around it and stuff too. So it actually really wasn't returning the result like we said in the prompt. But basically it tries to find just that mathematical equation with regex. And so I was trying to be fair with the base model too previously. And this is actually something you'll want to do in eval sometimes is like, you start with a base model and you're trying to get it to code. The base model, if you're using an instruct model, will output usually a little bit more explanation text too, not just the code. And so if you want to be fair with it, like you want to extract the actual piece and say, even if it had kind of more rambling text around it, it wasn't the exact outcome that I was looking for. It actually did solve the problem. So I was trying to use this in some of the other applications I was using to like code or whatever. I didn't want to just say that the base model was completely off, even if it had a little bit of extra text around it. And this just creates those problems, generates the countdown problem, where it takes a base number and then basically makes 3 numbers that it knows it can result that it can add up to, or with like adding, subtracting, multiplying, etc. And we have our first task that we see in our platform here. We can see that we have this wrapper on top. So we had defined that CPU task. We're enabling caching with just this decorator in there. So again, this is rest of it's basically like a Python function, except for we also enforce strong typing. So we're saying CPU task, cache equal. So every time we run this pipeline, it's not going to download the prep data set again. With this auto one, if you do change the code down here, or you pass in a different input parameter to it, then it will rerun it. So the cache auto is nice. Like if you are doing hyperparameter tuning even, and you're adjusting things, but then you come back to the same hyperparameter for that type of data or whatever, it will hit that cache and it won't have to run it again, which is super nice. And this is just creating examples from that function above, basically. And then we're downloading a model. Again, this also has caching enabled, so it won't re-download every time. Using the 0.5 billion parameter model is pretty quick to download every time. But if you're using like a 7 billion parameter, then obviously that takes a lot longer. And then if you're doing way bigger, that takes a lot longer too. You don't want to do that every time. So you just rerun the workflow. It's going to hit the cache and just pull in that model, which is nice. And Flight has this concept called flight directory and flight file. So I'm not sure if you've worked with containers a lot before, this will be familiar. But if you haven't done a lot of containerization work on like cloud, it's a little foreign at first sometimes when you come in. Like if you do something like you download a data set in that container, and then that container spins down, well, where's that data set? If you didn't save it anywhere, then it's not going to be anywhere. So you usually have to push that out somewhere. You write it to S3, you save it to Hugging Face Hub, etc. Flight has this concept, like when you set up Flight or you're using Union, you set it up to write to something like an S3 storage or blob storage on whatever cloud that you're using or on-prem. And then when you call a flight directory or flight file, it'll automatically write that to that storage. So when you say you're returning this flight directory here, it's going to be written to a storage now, and then any other task can reference it from anywhere. So if you're writing large files, this is really, really nice. And you kind of forget that you're working with containers when you start using this, because when you write something as a flight directory, then it still exists after the container spins down. I gotta get a little drink of water here. Somebody said I was frozen, but people said it was still fine. So it might be their internet connection, but sometimes it happens. So let me know if that is the case for other people. All right, so then we have our training task. We pass in a whole bunch of parameters here. I have comments for them, but I think we'll just go in and where they're actually at in the GRPO piece, we can talk more about them. We import our GRPO config from the transformers library, again, from the TRL transformers library. We just have some logging here. We're going to download that data set that gets passed in. Again, that's that flight directory. We're calling .download. Now it's going to exist inside of this container. We do that with the data set and also the model path there. And then we have our parameter efficient configuration. piece, which we talked about with the LoRa config. So we're adding the matrix here. Again, they make this really easy with their parameter efficient fine-tuning library, where you can do LoRa. They have another library, bits and bytes, that does the QLAR part too. So we don't have it in this example, but if you want to load things into the 4-bit things, then you can do that really easily as well. We're going to scroll down. A lot of this HTML stuff is actually because we're building this report here, and it's getting rendered as it runs kind of in real time, which is, again, really nice. So it does your experimentation tracking live here. You can actually set up like refresh rates, which is super awesome. So it's not refreshing all the time, or you can hit manually refresh and it'll show the latest version of, where your model's at as it's running. And this is just basically getting the metrics for that chart that we're writing out. So there's a lot of little extra code here. This is the reward function. So again, depends on what you're doing. You're going to have to come up with time. Somebody said, is there any reason you didn't use something like weights and biases or MLflow to track this? In my case, because I'm using Union of Flight, I don't really have to. It's all kind of tracked in here. So again, every time I run this pipeline, like it's all versioned. If I go in and, which is this one. So like I've run this several times. Every single run of this, I can go click into it. I can go back to train and I can look at the report here. I can even pull these metrics out and like compare them against each other in another report. So I know like weights and biases has some other nicer features around it. Like we're not a full experiment management platform with like the comparison piece between all these different models and stuff. But for my case, I don't really need to, because I do have everything versioned here that I need. And I can just go back into my specific versions and then pull out what I need. Same with artifacts. So you mentioned like MLflow for versioning and tracking this as well. Every one of these, like when I return something like the flight directory, that lives now basically as something returned from one of these tasks or from the entire pipeline. And now it exists like in an S3 bucket. And then I can just pull this down. And in fact, actually, hopefully I'll have time here. I got to go a little bit quicker. We actually take the artifact and then serve it in a fast API that's also using the Flight SDK to like basically manage the artifact, pull it in, and then serve it here and run it with inference. See if it solves the puzzle. Oh, it's got to spin up the fast API now too. So in short, you can, like, in fact, we have direct integrations with, I think, MLflow for sure. I think weights and biases as well, because they have some other features that are really nice that we probably don't have in here. So if you do want to use them, you should, but you don't have to probably for some of the use cases. Like if you just want to look at your, again, you make a better chart than I did here, but look at your training metrics, they'll be all logged here. I hope that answers your question. So you should, if you like features around them, definitely not saying don't. You don't always need it. The reward function here, basically, this is just saying, is it correct? Is the puzzle correct? In mathematical, we have a pretty simple math puzzle here. So we can say correct, yes or no. And we're just having a binary reward. So you get 1 or 0. When you're working with RL for more complex applications like code, for example, you might not want to do binary. Maybe you do, depends on your application. But you might want to have more of a gradient. Like if some of the tests pass, then it gets some reward, not a completely 0 reward. But because our thing today is just like, so it is a very binary, did it do it or not kind of thing. We're using a binary reward, and all we're doing is just saying yes or no, basically, is correct, is not correct. Give that as a reward back to the policy. But this is something you're going to spend some time on if you have a more complex application and figure out. You probably want to run. You'll probably run multiple runs with different rewards and see what happens. And then this is the actual GRPO config. Again, pretty simple because they make it really easy now with all these awesome libraries. Import the GRPO config. We have the number of epochs. A lot of stuff is going to look pretty familiar if you've done, like, I don't know, supervised fine-tuning, etc. The beta is the KL divergence back to the model, which is basically, I forget what KL even stands for. It's in the paper we just read it, right? Where was it? They just say KL divergent too. Oh, there. Kolbeck Leibler. I always say KL. I think most people say KL. But basically, this is just comparing the outputs, basically, like the differences between what's good and bad. A way of calculating that gets passed back to the model. But you can change that as a parameter. And that's kind of it. Like for setting up the GRPO stuff, like that's it. The rest of the library kind of takes care of the entire algorithm piece here, basically for you. And then you just call the GRPO trainer. You pass in those configs, and you can pass in the PEFT config for the parameter efficient fine tuning, and then it'll do the training. So if you run this, that's a training piece. The eval just reads in the model and then sees how many is correct or not. And a lot of that code is, again, just kind of building a report here for the evals. So how many succeeded, how many didn't. We compare, again, that base model to the GRPO supervised fine tuning one. And then if we go down, again, I'm going to go a little faster here. We have a pipeline, and that is the entire pipeline task here, which runs all these other subtasks. If you have used Flight 1 in the past, there used to be a workflow decorator. Now in Flight V2, just everything runs in a task here. Like so task just calls other tasks, and it can be fully dynamic. You can write if statements, you can write loops, etc. It's just calling different tasks here, and it'll fan out into different task environments. We didn't do it here either, but you can fan out with async IO or something called map tasks. So if you wanted to run like 100 of these in parallel, you could do that with async IO or a map task, like say spin up 100 of these, and it'll spin up a container with that compute that you define. So you need like 100 GPUs if you're going to do it in that case. And again, because this was going to be a workshop, I didn't want to take up all the GPUs in the cluster, so I didn't have any fan out here. But you could fan out like training into multiple containers if that works for the type of thing that you're doing. But basically, again, there's some code here that is creating an HTML report. But inside here, we're now just calling those tasks that we defined above: prepare data, download model. These then get these variables, and they're passed to the other task, which is train. So it knows in which order to call these, and it'll just pass the flight directory in this case from these into our next tasks as the containers spin up. And then it does the evaluate one. So that's our whole pipeline piece. And then on the deployment piece, I just showed it briefly, but if I go to, why did I scroll up so far? If I go to this serve.py, we have pretty similar SDK for building an application where you can then, an app can be a host and model, like add an endpoint like Fast API, or we have a VLM or SGLang integrations too. So if you're looking to spin up a VLM app, you can just use the same SDK that I'm going to show here in a second. But this hosts our model and then hosts an application running on compute. And you get an SDK that's kind of similar to like we saw, where it's really easy to define the compute to run on or orchestrate the compute for these hosted apps. So we just have this flight resources. These are the compute that it's running on. So it needs a GPU to spin up the model on the Fast API. You can do scaling. So in my case, it scales down to 0 or 1. It'll scale down after a certain amount of minutes when it's not used. And you can also set up scaling factors, like how many people are visiting before it scales up. You could set scaling to 1. So there's always one replica up, but then scales as more people are using it. Requires auth equal to false. By default, this is true. So actually, I could share the app. And let's see, did it spin up the... Okay, yeah, it's spun up now. So I can't share this if you want to play around with it. This is the model is hosted. And we can see if it solves these problems or not. This one, it works. This one, it works. This one, it does too. I'm sure it's going to fail on some of these. Because it was only... okay, yeah. I was like, it wasn't perfect. There's definitely some it would fail on. Okay, cool. So you can see it's doing a decent job when we play around with it here with these examples. And the evals improved, again, a lot if we just train it for more. And or potentially give it more data. It's probably going to do even a better job here. Again, I was trying to keep this under an hour so we could train it live, but that didn't happen. So that, yeah, it makes it really easy to deploy. In this case, it's a Fast API environment that the model is at. And then we have a Gradio app, again, using the same type of SDK. You can define what packages you want, define the container image, everything you want it to run in, and then give it those resources. So really easy to manage kind of the entire training lifecycle, but then also the serving lifecycle if it's something you're serving like this, all together without touching Docker. It's all in a Python SDK. Claude or Codex does a really good job of writing this code too, because it's just pure Python and then adding some decorators basically on top of it, and then defining compute metrics and stuff like these task environments. So really, really easy for you if you're manually writing code, but also for your agents if you're writing code as well, to basically generate these whole pipelines with that scaling, versioning, etc., kind of all built in. And we have like 5 minutes because, like I was saying, I kind of have a hard stop, unfortunately, at 1. So let me get to questions here. And I know I went through some of this kind of quick, so let me share the code repo again one more time as well. This is math puzzle 1 again, and then here is the code 1 as well. So this code 1 is pretty similar, but if you look at the training part, it uses a sandbox and runs the code examples in the sandbox there. And as a, I forget if I pushed up the change, but as a Q LoRa, I think I did, yeah, as a Q LoRa example in there too. All right, let me catch up on chat here real quick. Someone said useful talk. Thanks. Yeah, sorry, Trent, that I think you were the one who said you came for the workshop part. Sorry I couldn't hand over the code and have you run it today. Usually I try to do that. And it was good feedback to see you too. Yeah, mix. Some people just like watching, some people like running the stuff. Great feedback. Like I was saying, I wasn't sure. So I'll still try to do workshops is what I'm hearing. And it's also okay if you don't run it too, you can just watch it. But I think that kind of still hits what most people want if I read the comments correctly. Oh, and I didn't even see that was Steve talking about MLflow. and then he said cool, I think, on my explanation. Also, he asked about trying this with OpenEnv, or did I miss that part? So I didn't do it in this workshop, but I actually have tried this a little bit with OpenEnv in the past. And I did one of the Friday streams is on OpenEnv, and that's where I actually did that as well. In OpenEnv, you can also use so OpenEnv, actually, let me bring it up because it's a really cool project by PyTorch. And I might not be able to get all these questions, unfortunately. So 2 things. Here's the OpenEnv environment. Really cool. I'll talk more about that in a second. But if you have questions and I wasn't able to get to it, I would love to answer them. If you want to ask them again in the flight Slack, I will get to you. I'll get back to you after my next meetings if I don't get to them in the next 2 minutes. So OpenEnv is I don't know, where'd I go? Did I already? Okay. Oh, okay. Wait, Hugging. Okay, yeah, I forgot. It's Hugging Face and PyTorch. I didn't know it was under the Hugging Face domain in GitHub. I thought it was under PyTorch, but I know they're both contributors to it. But OpenEnv gives you basically an API to define reinforcement learning environments. So it has like steps and resets, etc., kind of just built in, which is really nice. And I actually use this to build. I won't have an example that I can pull up, but I use this as actually building like a little maze environment that renders in a flight report here. And it was kind of cool. You could see a replay of the. I tried it both with an LLM and then also just with more traditional reinforcement learning, having it navigate like a maze. And it was kind of cool to see the playback directly in a report here. And somebody said that, sorry, I might have missed some. Oh, so someone asked, does Flight have a Discord by any chance? We don't have a Discord. We have the Slack channel. So it's always the question right now, do you use Discord or Slack? And some people really don't like Slack. Some people don't like Discord. A lot of people still use Slack for work, though. Like I know I'm on Slack more, so I'm more likely to go poke into a Slack community if I'm already joined it. All right, yeah, and sorry, I have to hop off here in a minute, so I apologize. I don't think I got to every single question. Again, join the Slack channel, or you can also connect with me on LinkedIn, ask me there, and I will get back to you. But I have to hop off here in a second, so I'm going to end the stream in a minute. Any last final thoughts or anything people want to throw out in the chat? Do so now. But I'm going to have to wrap up the stream here in a minute. Sorry for the crunched time today too. We're getting ready to launch some really cool stuff with Flight. So keep an eye out. If you're interested, try out the dev box. Again, you can set up just locally. You'll get actually, do I have my dev box running? You'll get a whole environment just like what we saw, but it's this purple and white UI. And yeah, you can do your runs in here. And oops, I don't think I have my port forwarded right now for the local host, but you can run it basically everything that we saw today locally in like a Flight environment. But you need your own accelerator if you want to do any of the stuff like GRPO or fine tuning. But you can use it for agent development out of the box on like basically any computer. So, all right, that's it for me today. Hopefully, again, sorry for the cluster part where you can actually follow along potentially, but hopefully you still found it interesting and maybe a super interesting quick intro to GRPO. I know it was super fast on a lot of stuff. I'd recommend, reading the paper, looking up some more examples. I think Hugging Face even just has some in the TRL library as well. So thank you, everyone. I'm going to wrap up the stream. Hopefully I'll see some of you at another event or on Slack or some other messages somewhere. Brian said, thanks. Yeah, no problem. Thank you again. All right. I'm going to wrap up the stream. So goodbye, everyone. I'll talk to you later.